In this part of section 13.1, we're going to be looking at finding the domain of a function of two variables. For this function of f of xy equals the square root of 4 minus x squared minus 4y squared, we want to find the domain. And when we're taking the square root of something, we want to make sure that whatever you're taking the square root of is greater than or equal to 0. So we're going to set up an inequality to say that what's underneath the square root, 4 minus x squared minus 4y squared, must be greater than or equal to 0 in order for you to get a real number out of this function of two variables. We can rearrange this a little bit, and we can add x squared and 4y squared to both sides to get the inequality. 4 has to be greater than or equal to x squared plus 4y squared. We can begin to notice that this is going to look like an ellipse, but we want to get it in the form of an ellipse. An ellipse is in the form of x squared over a squared plus y squared over b squared is equal to 1. So if we divide by 4 on both sides of the inequality, that's not going to change the direction of the inequality. We're going to get 1 is greater than or equal to x squared over 4 plus 4 divided by 4 is going to be 1, y squared over 1. This is now looks a lot like the equation of an ellipse, but now we're looking at it as an inequality. If I reverse the order of this inequality, I get the inequality x squared over 4 plus y squared over 1. All this side has to be less than or equal to 1. So I'm looking at it this way. To describe the domain, we could look at a graph of the ellipse. We want to find all the points xy so that the x squared over 4 plus y squared over 1 is less than or equal to 1. So we want to find all the points that are inside this ellipse. We want to go 2 units in the x direction and -2 units, and we're going to go up 1 unit in the y direction and down 1 unit so that we can sketch the graph of the ellipse. Quick sketch here. The domain are all the points xy that are inside this ellipse. Because this inequality is strictly less than or equal to 1, that's going to be all the points that are inside or on this ellipse. So your domain is the set of all of those points within or on that ellipse. Let's look at this function of two variables and describe the domain. F of xy is equal to the natural log of xy minus 6. Now, think about the natural log. You can't take the natural log of 0, and you can't take the natural log of a negative number. So what's inside, what we call the argument, what's inside here has to be greater than 0. We set up an inequality. Xy minus 6 must be greater than 0 in order for this function to be defined. We can rearrange this inequality. We can add 6 to both sides to get the inequality x times y must be greater than 6. But what does that look like in terms of a graph? What are all the points xy that satisfy this inequality? Well, we've got to think about this in two ways. If x is a positive number, then we could say something about this inequality. And if x is a negative number, we could say something else about this inequality. So let's suppose we're going to say that if x is greater than 0, if, in other words, x is positive, then this inequality, xy greater than 6, when we divide by x, and you're dividing an inequality by a positive, the direction of the inequality does not change. So we have y is greater than 6 over x. That's if x is greater than 0. But if x is less than 0, in other words, x is a negative number, when you take that inequality and simplify it by dividing by x, you're dividing by a negative, and that changes the direction of the inequality. The greater than becomes a less than, and we get y is less than 6 over x. So looking at this graphically, when x is positive, y has to be greater than 6 over x, and when x is negative, y has to be less than 6 over x. Let's do a quick sketch of the equation y equals 6 over x. You can use a calculator, make a table of values, and look at the graph. This graph has a vertical asymptote. In fact, when x is equal to 1, y is equal to 6. X is equal to 2, y is equal to 3. When x is equal to 3, y is equal to 2. I'm making a really quick sketch here. And since this is an inequality that doesn't have the equal sign, it's strictly greater, strictly less than, I'm going to be connecting those points with a dotted line. Okay. You can also look at points over here when x is negative, y is negative. Okay, so it's going to look roughly something like this. Now, when x is positive, all the y's have to be greater than 6 over x. So that's going to be the collection of all the points above that dotted line. When x is less than 0, y has to be lower than that. So that is your domain, would be all the points within that shaded yellow region. Again, this is an infinite domain. It's going to be everything outside that dotted pink line. Okay, for this example, we want to sketch. If we were asked about the domain would be all real numbers because there's really no restrictions for x and y. X can be any number, real number, and y could be any real number. You don't have any fractions to worry about dividing by 0, and you don't have any square roots to worry about taking the square root of a negative number. So in this case, the domain is all real numbers. What you can do to sketch this function of two variables, you can treat this f of xy as z. Z is equal to 6 minus 2x minus 3y. And perhaps you recognize that this is the equation of a plane. And the way we sketched planes back in chapter 11 was by sketching the x-intercepts, the x, y, and z intercepts. So if you let x equals 0 and y equals 0, and you simplify this equation, you get z is equal to 6. And you're plugging in 0 for x and y. That'll give you your z-intercept. If you let x equal 0 and let z equal 0, you can solve for the y-intercept. And this is your z-intercept. We can find the y-intercept, and then we'll find the x-intercept. To find this y-intercept, we let x and z both equal 0. So plugging in 0 for x and 0 for z, our equation becomes 0 equals 6 minus 2 times 0 minus 3y. When you simplify this equation, you get 3y equals 6, so we get y equals 2. Y equals 2 would be the y-intercept. Now to find the x-intercept, you're going to determine what the value of x is when y is equal to 0 and z is equal to 0. That's finding the x-intercept, and we can do that by plugging in y equals 0 and z equals 0 into the equation. We get 0 equals 6 minus 2x minus 3 times 0. And when you simplify this, you get 2x equals 6, so x has to equal 3. So we found the x, y, and z intercepts. We can sketch this. This we have x, y, and z, so we need a graph, a 3D graph, where our x-axis is coming out to the lower left, our y-axis is coming out to the right, and the z-axis is up and down. Locate the z-intercept at positive 6, the y-intercept at 2, and the x-intercept at 3. We can connect those intercepts to form a triangle, which is a portion of the infinite plane.